Hi everyone, welcome to goclasses. In this lecture, we will study RISC computer versus CISC computer, or I can say RISC architecture versus CISC architecture. You can say these are two instruction set architectures. Okay, what are these? RISC, CISC. These are two instruction set architecture. So there are two type of instruction set architecture. One is RISC, one is CISC. First, let's see what is the full form. So remember, there are two type of instruction set architecture. We have already seen what is instruction set architecture in the previous lecture. Yes or no? Instruction set architecture that we have already seen. Now you can divide the instruction set architecture into two categories. One is RISC and one is CISC. CISC means complex instruction set computer. Okay, what this means? This means complex instruction set computer, or you can simply say complex instruction set architecture. Okay, so what is CISC? CISC means complex instruction set architecture. Basically, C means complex. Here, C means complex, and here this R means reduced. So what is RISC? RISC, the full form of RISC, that is reduced instruction set architecture. Okay, reduced instruction set architecture. Now let's see what is the difference between these two and what are these. First, let's understand what is CISC and what is RISC architecture. So first, I'm telling you that basically instruction set architecture you can divide into two categories. One is CISC instruction set architecture, another is a RISC instruction set architecture. Okay, so now let's see what are these, and then we will see the differences of these two. See, in the old days, like in the 1960s, in the 1970s, the RAM was very expensive. Yes or no? You already know. Maybe you have seen the photo of old days computer. The first computer, have you seen the photo? There was a very big computer. Okay, so basically in the old days, let me tell you, the RAM, I can say the memory, okay, that was very expensive. That was very small and very expensive. In the old days, 1 MB, 5 MB RAM was used in the computers. Okay, so that is the reason we will see, that is the reason CISC architecture was used. Don't worry, now you might be thinking, what is CISC architecture? What is RISC architecture? That I will explain. But remember, in the old days, in the very old days, this memory was very expensive. Nowadays, time is expensive. Yes or no? Nowadays, memory is very cheap. Okay, you can purchase 16 GB memory. Okay, 16 GB RAM you have in your computers. Okay, maybe 32 GB RAM you have in your computers. So you can see nowadays memory is very cheap, but time matters. Okay, so now let me tell you one more thing, that nowadays we use this RISC architecture. This is used in the modern computers. Okay, so when I say modern computer, that means RISC architecture. Okay, the modern computers means your computer, my computer, all these computers, they are using RISC architecture. Is this clear? This is CISC architecture. This was used in the old days. This was used in old days. This is now this is no longer used. Is this clear? Now this is not used in modern computers. In modern computers, we don't use this. Okay, so remember, in our modern computers, in your computer, in my computer, in all these modern computers, we use RISC architecture. Okay, these are instruction set architectures. This CISC architecture, this was used in the old days. Now, as I told you that in the old days, memory was very expensive. So what was the priority? What was the priority in old days? Let me tell you. In the old days, memory was very expensive. So program must be small. Yes or no? If you have only 1 MB memory, let's assume, or maybe 5 MB memory, you are using only 5 MB RAM, then your program must be very small. Do you agree with me? Yes or no? Your program, the program that you are writing, let's assume you are the assembly language programmer. Okay, you are writing the assembly language program. Now you tell me, if you have only 5 MB RAM or maybe 1 MB RAM, then you will try to write a very small program. Yes or no? You will prefer very small program. That is the idea of CISC. So what CISC does, that is the idea of CISC. CISC means this CISC focuses on, I can say it focuses on that program must be very small. You are the assembly language programmer, so the program must be very small. Okay, your program must be very small. Okay, now let's see. So you can see in the old days, this memory was expensive. So CISC architecture was used. Okay, because remember what CISC does, tell me. CISC focuses on reducing the size of program. Yes or no? What is CISC architecture? CISC architecture, this focuses on reducing the size of the program. This will focus on reducing the size of the program. So you can see when memory is expensive, then CISC architecture was used. Okay, nowadays we use the RISC architecture. Okay, don't worry, this will become more and more clear. First, let me give you one analogy. The analogy is something like this. Understand the CISC idea versus RISC idea. Let's assume there are two businessmen. Okay, there is this person A. This person A wants to do the business. Okay, some business this person wants to do. Some, okay, online business maybe this person A wants to do, but there is a limited budget. Okay, this person starts with a limited budget. Is this clear? So this person A, this will start with very limited budget. Now you tell me, because this person A is starting with a very limited budget, okay, then in this situation, what this person A will do? The person A will do everything. Yes or no? The person A will do everything. The person A will do, for example, calls. If some call will come, the calls also this person A will handle. Yes or no? This person A will handle the calls also. This person A will handle the mails also. This person A will handle the actual work also. Okay, that actual work also this person A will handle. If some traveling needs to be done, this person A will do that traveling also. Are you getting my point? Basically, all the work this person A has to do. Now you tell me, in this type of situation, can I say the actual productivity will be less or more? This person A, this starts with a limited budget. So this person A will take care of everything because there is a limited budget. In this type of situation, the productivity will be less or more? The productivity, I'm asking the productivity, basically the actual work. Okay, the productivity will be less, yes or no? In this situation, I can simply say that productivity that actually will be less. Okay, agree? Yes or no? Now, this is the idea of RISC. Actually, this is the RISC idea. Let me tell you, this is the RISC idea. This is the CISC idea. Sorry, this is the CISC idea. This is the approach of CISC. Okay, is this clear? Now, what is the RISC idea? The RISC idea is something like this, that let's assume this person wants to start a company, this person B, this person, and let's assume there is no limitation on the budget. Okay, so basically budget is there. Okay, he has good budget. Oh, so now in this situation, what this person can do? Tell me what this person can do. The person can hire someone for calls. For calls, he can hire, let's assume some person C. Yes or no? For mails, this person can hire person D. Okay, yes or no? For actual work that this person B itself can do, this person B can do. Okay, and if some traveling needs to be done, then that person, he can hire some person maybe E. Are you getting my point? Is this clear? Okay, so this is the idea of RISC. This is the idea of RISC. Tell me, in this situation, the productivity will be more. Agree with me? Yes or no? Different people, they are handling the different work. So in this situation, there will be, I can say, productivity will be more and parallelism will be more. Do you agree with me? See, here you can notice the same person is handling all the things. So can I say productivity less? Can I say parallelism is less? Please tell me, is this clear? The parallelism is less. Okay, parallelly to work, this person cannot do. Agree with me? Yes or no? Parallelly, the person is handling the call also, the person is doing the work also parallelly. Basically, parallelism is very less. Do you agree with me? I can say optimization is less. Okay, yes or no? So you can see productivity less. I can say parallelism is also very less. But in this situation, you can see this is the RISC idea. Okay, these two people, they can do work in parallel. These two people, they can do work in parallel. So I can say this is the RISC idea. In this situation, can I say parallelism is more? Okay, yes or no? This parallelism. So this is more. Okay, and similarly, you can see productivity is more. Is this clear? Please tell me. So here productivity, this is just an analogy. Remember, this is just an analogy. Now let me tell you the actual thing. Now let me tell you the actual concept, what actually happens. See, in the old days, the memory was very expensive. Okay, so in the old days, this CISC architecture was used. Okay, this CISC architecture. What this CISC architecture does? Tell me. What this CISC architecture does? This CISC architecture, this focuses on minimizing the size of program. Is this clear? This focuses on minimizing the size of program. the size of code, the size of program. Is this clear? If someone asks you what the idea of CISC, then what you will take, then what you will say? Please tell me. If someone asks you what is the idea of CISC, what you will say? You will say this CISC architecture, this focuses on minimizing the size of the program. Okay, is this clear? This focuses on the minimizing the size of the program. And what is the RISC idea? And what is the RISC architecture? This RISC architecture, this focuses on minimizing the time. This focuses on minimizing execution time. Okay, is this clear? This focuses on minimizing execution time. So remember, if someone asks you what is the idea of CISC architecture, what is the idea of CISC computer? These CISC computer, they are old days computer. Okay, in the old days, this CISC architecture was used. Nowadays, we use the RISC architecture. So what is the idea of CISC architecture? If someone asks you in the interview, if they ask you what is a CISC architecture, then what you will say? Then what you will say? You will say that CISC architecture focuses on minimizing the size of the program. Okay, RISC architecture focuses on minimizing the execution time of the program. Okay, now you can see that in the old days, CISC architecture was used. What is the reason? Because memory was very expensive, memory was very small. Okay, so you can see because memory was expensive, so what will happen? Memory was expensive, so program size must be small. Agree with me? Program size must be small. Okay, so number of instructions per program must be less. Agree with me? Number of instructions in the program, that must be less. So tell me, which instruction set architecture you will use? Tell me which type of instructions you will use. In the previous lecture, we have seen there are different type of instruction set architecture. Okay, stack based architecture, memory architecture, register architecture. So tell me, this CISC computer, this will use memory instruction, or this will use register instruction? Please tell me. Let me know. This CISC computer, I am talking about CISC computer. This CISC computer, it will use memory instruction, or it will use register instruction? It will use memory instruction. Very good. Yes or no? So you can easily see that it will use memory instructions. Okay, so memory instructions are used in CISC. Is this clear? Please tell me. So did you clearly understand what is CISC? What is the idea of CISC? You know, what is the principle of CISC? Why this CISC was used in the old days? Did you clearly understand? See, very simple point. In the old days, memory was very expensive, so the size of program must be small. Means number of instructions per program must be less. Okay, and this is the idea of CISC. This is the idea of CISC. Is this clear? So in this CISC, remember, the focus is on minimizing the size of the program. If someone asks you what is the idea of CISC, what is CISC architecture? So the CISC architecture simply says that the size of the program must be small. Okay, so we use memory instructions. What we use? We use memory instructions we use. Is this clear? Memory instructions we use. Is this understood? Please tell me. Let me know. And what about RISC? What about RISC? The focus of RISC is on minimizing the execution time. Agree with me? Because in the modern days, what happens? The memory is cheap. Yes or no? The time is expensive. Memory is not expensive, but you can see time is expensive. So memory is cheap. You can put large program. Yes or no? Your program can be very big. Okay, you can write 1,000-line program, 1,00,000-line program. So your program can be very big. So remember, memory is cheap. We need fast execution time. So optimization is needed. Okay, so program must take less time to execute. The execution time must be less. So time per instruction must be less. Per instruction, you should take less time. So tell me, if you want per instruction, if you want less time, okay, per instruction, for every instruction, if you want to take less time, then tell me which type of instruction you will use, register instruction or memory instruction? Please tell me. You want to minimize the execution time of every instruction. Time per instruction must be less. So which type of instruction you will use? You will use register instruction. Yes or no? We will use register instruction. So is this clear? Please tell me, did you understand what is RISC, what is CISC? What is the idea of RISC computer? What is the idea of CISC computer? Please tell me. Is this clear? So remember, RISC versus CISC. You can see CISC means complex instruction set architecture. RISC means reduced instruction set architecture. These are two different type of architectures. These are two instruction set architectures. Remember, CISC architecture uses memory instructions. We have already seen. And RISC architecture uses register instructions. Tell me one thing. What is the reason CISC uses memory instructions? What is the reason? Tell me. If someone asks you, what is the reason why CISC uses memory instructions? What your answer will be? If I ask you, why CISC uses memory instructions? Because the focus of CISC, the idea of CISC is to minimize the program size. Is this clear? Just remember, the focus of CISC computer, that is on minimizing the program size. And the focus of RISC computer, that is on minimizing the execution time. So RISC computer will use the register instructions. Because remember, here the focus is on time, execution time, and here the focus is on the space. Here the focus is on minimizing the program size. Here the focus is on minimizing the execution time of the program. Please tell me, understood? Let me know. So remember, if you see nowadays, let me tell you, no one is using CISC computer. So this is from Stanford. This screenshot I have taken from Stanford. You can read this. Today, you can see Intel 86. That is the only chip which uses CISC architecture. See, read this line. This paragraph is taken from Stanford. Read this. You can see today only this Intel chip is there. This particular Intel 86 chip. This is there. That is the only chip we use which uses CISC architecture. Nowadays, we don't use CISC architecture. What is the reason? Please tell me. If someone asks you, nowadays we don't use CISC architecture, what is the reason? Because nowadays memory is very cheap. Yes or no? Memory is very cheap nowadays. You can purchase 16 GB RAM, 32 GB RAM. You can have, yes or no, in your computer you can have 8 GB RAM. So nowadays you can see RAM is very cheap. So you can easily see this advancement happened because of computer technology. You can see the price of RAM. You can see the price of RAM has decreased dramatically. Okay. In old days, in 1977, 1 MB of RAM was costing $5,000. So please tell me, just think about it. You are in 1977 and you are using a computer. 1 MB of RAM is taking $5,000. So tell me, your focus will be on the time or your focus will be on the reducing the instruction size? Please tell me. Reducing the, reducing the program size. What your focus will be? You only have 1 MB RAM. And remember, 1 MB RAM is costing you $5,000. So what your focus will be? On reducing the program size or on reducing the execution time? What will be your focus? Your focus will be on the decreasing the program size. Yes or no? So that your program you can put your program in the RAM. Agree with me? Now you can see after some time in 1994, you can see the main memory was costing only $6. So you can see basically the cost of main memory that is decreasing. So that is the reason nowadays we use RISC computer. Okay, is this clear? Please tell me, did you understand all these points? Are they clear? Let me know. Please tell me. So what is the RISC approach? What is the CISC approach? So let's see the CISC architecture. So the CISC idea, the CISC approach, that is the primary goal of CISC architecture. What is that? That is to complete a task in as few lines of assembly code as possible. Is this clear? Let me know. Read this line. We want to complete a task, means we want to write a program in as few lines of the assembly code as possible. Okay, you are the assembly language programmer. You want to write a program, then you want to make sure that your program has few lines. Okay, yes or no? So you want to complete a task in as few lines as possible. Very simple. This is the idea of CISC. CISC means Garib Aadmi. Yes or no? Yes or no? Can I say? CISC means Garib Aadmi. RISC means Amir Aadmi. Okay. So what is the RISC approach? This RISC will focus on minimizing the execution time. So you can see RISC processor, they will use simple instructions that we will see. They will use simple instructions that can be executed within one clock cycle. Okay, means this RISC approach, this RISC processor, they will use instructions, simple instructions they will use, which can be executed in one clock cycle. In one clock cycle, you can execute one instruction. Okay, so this is the complete idea. Is this clear? Let me know. Please tell me. Now, let me ask you a very simple question. This example we have seen in the previous lecture also. I'm again taking this example. Okay, let's assume that this code you have, okay, A, B plus C, and let's assume that D, B minus E. Okay, so this is the code. So let's assume that all these A, B, C, these are stored in memory. A, B, C, D, E. Okay, these are in main memory. Okay, just let's assume that these are in the main memory. Okay, now you tell me, quickly you tell me. So remember, this A, B, C, D, E, these are in the main memory. What we want to do? We want to add B plus C, and then we want to store in A. And then what we want to do? We want to do B minus E, and then we want to store in D. Now you tell me one thing. This CISC approach, what that? What the CISC approach? What the CISC architecture? What the CISC architecture will do? Please tell me. This will use memory instructions, yes or no? This will use memory instruction. Now, why it is using the memory instruction? I will tell you. What is the reason it is using memory instructions? See, this CISC architecture, this will use memory instruction. Why? What is the reason? Because you can see already these are in the main memory. Okay, so what will be the assembly language code? Tell me, what will be the assembly language code? Your assembly language code, you tell me. What will be the assembly language code in CISC? CISC will use memory instruction. Why it is using memory instruction? That I want to tell you. I want to tell you what is the reason CISC will use memory instruction. Okay, that is what I want to tell you. So tell me, what will be the assembly language code if you use memory instruction? Very simple. First you will add, okay, add B, C and store in A. And then what you will do? Then you will subtract, okay, from B you subtract E, and then you store in D. Yes or no? So tell me one thing. How many instructions? Let me know quickly. Let me know quickly how many instructions. How many instructions are there? Only 2 instructions. Only 2 instructions are there, right? Only 2 instructions. You will only have 2 instructions. Agree with me? So if you are the assembly language programmer, then you will write only 2 instructions to carry out this task. This is the task that you want to carry out. Okay, all these are in the main memory. Now this data is in the main memory, A, B, C, D, E, all of them are in the main memory. Now you want to carry out this task, then you will write only 2 instructions in the assembly language code, because you are the assembly language programmer. Okay, very simple. Is this clear? So you tell me, if you have only 2 instructions, then it is better when you then it is better if you are, I can say, if you have less RAM. Agree with me? If you have less RAM, means your RAM is, let's assume, 1 MB or 5 MB, then it is better, right? Yes or no? Agree with me? Please tell me. If you have only 1 MB of RAM, then in this situation, this is better, because only 2 instructions you have to write. As an assembly language programmer, you are the assembly language programmer. So that is the reason we use memory instructions. Is this point clear? What is the reason CISC uses memory instruction? Is that point clear? Because the focus of CISC is to minimize the size of the program. Now you can see the program has only 2 instructions. Okay, that is the focus of CISC. The CISC will focus on, what are the focus? Tell me. CISC focuses on minimizing program size. Minimizing program size. Program size. Okay, you can see here, you can see only 2 instructions are there. And that is the reason this CISC architecture will use, CISC computer will use memory instruction, so that we can have less number of instructions. Okay, your program size should be very small. But now you tell me, how many main memory access? How much time it will take? Okay, let's see the time. How much time it will take? Tell me how many main memory access? Because remember, memory access is the most expensive operation in terms of time. You already know this. When you access the main memory, then it will take many clock cycles. Okay, if you are accessing the main memory, it will take many clock cycles. So you can see, if you have to access main memory, that is very expensive from time point of view, from execution time point of view. So tell me, if you have this program, if I give you this program, then how much time it will take? Please tell me, how many memory accesses will be there to execute these 2 lines? Only 2 lines are there. To execute these 2 lines, how many memory accesses will be there? You can see the answer will be 6. What is the reason? The reason is very simple. See, okay, what this instruction will do? Focus on the first instruction, add A, B, C. What this instruction will do? Remember, these are already in the main memory. What we need to do? We need to add B plus C, and we have to put in the A. So what we will do? First, this B is in the main memory. So first, this will go to the CPU. First, this will go to the ALU. There is a ALU. So this will go to the ALU, 1 memory access. Okay, this is in the main memory. So first this will go to the main memory, then this will go to the main memory to memory access. Then ALU will do the addition. ALU will do the addition, and this result you will put in A. This result where you will put this result you will put in A. So overall, tell me for the first instruction, how many memory access? For the first instruction, first you will access B comma C, then you will do the addition, ALU will do the addition, and then you will store the result in this location A. So 3 memory access. Yes or no? Very good, very good. 3 memory access. Now you tell me about the next. What about the next instruction? In the next instruction, what will happen? You will access B, then you will access E, 2 memory access. Then ALU will do the subtraction. After subtraction, the result will be stored in location D. So there are 3 memory access. So you can see overall how many memory access? Total 6 memory access are there. Okay, only for 2 instructions you have for this task. This is your task. I can say this is the task. Okay, correct. This is your task. So for this task, you need 6 memory access in the CISC computer. Okay, because the CISC computer is focusing on reducing the program size. To reduce the program size, this CISC computer is using memory instruction. In the memory instruction, remember one thing, all the operands, they will come from main memory. We have already seen this. Okay, in the memory instruction. What is a memory instruction? Let me just explain this. What is a memory instruction? In the memory instruction, remember all the operands will come from main memory. That we have already seen. For example, if you do addition, then this is a main memory address. This is another main memory address. This is another main memory address. Okay, all of them, these are memory addresses. Okay, so all the operands, they will come from main memory. This is what happens in the memory instruction. And what happens in the register instruction? In the register architecture, what happens? In the register instruction, all the operands, they will come from registers. Okay, like R1, R2, R3. Okay, so you can see all the operands, they will come from registers. You don't have to access the main memory. Okay, you can see here, you can see the addition operation will access 3 main memory. Okay, will access memory 3 times. This addition operation will access memory 3 times. Okay, but you can see in this addition operation, look at this addition operation, all the operands are coming from registers. You can see all the operands, they are coming from register. So I can say there is 0 memory access here. Okay, here you don't need any memory access. Okay, now let's come back to our question. So this was the point. So you can see in this CISC architecture, 6 memory access you need. Okay, what about the RISC architecture? Please tell me, what about the RISC architecture? What RISC will do? What this RISC architecture will do? It will use register instructions. It will use register instruction. Register instruction it will use. Okay, so because the focus is on minimizing the execution time, this will focus on minimizing the execution time. Okay, we want to minimize execution time. That is the focus. The complete focus is on minimizing the execution time. So tell me, this RISC will use register instructions. Register architecture we will use. Okay, so for addition, if you want to do the addition, then everything must be in the registers. Do you agree with me? If you want to do the addition, then everything must be in the registers. Agree with me? Please tell me yes or no. In the register instruction, because the CISC computer, sorry, the RISC computer will focus on minimizing the execution time. So what it will do, it will use register instruction, means all the operands, they will come from register. So if you want to add, then all the operands should come from registers, but they are where? All the operands are present where? Please tell me. All the operands should come from register. Okay, in the register instruction, the name itself is telling you register. So all the instructions, all the operands should come from register, but where they are? They are in the main memory. They are present in the main memory. So first we have to load. Yes or no? So first we have to load. So what we will do, we will load this A, this B, we will load in what you can do, this B you can load in R1. Okay, what you can do, this C you can load in R2. Okay, this is what you can do. So remember, first you will load B in R1, this B you will load in R1. Then what you will do, then you will load this C in R2. And then what you will do, then you will do the addition. Okay, what you will do, you will do the addition of R1, R2. Okay, and then you will put the result in R3. The result is in the R3. But where we want to put the result? Where we want to put the result? We want to put the result in main memory. Yes or no? We want to put the result in main memory. This is the result we want to put in main memory. So you can use the store instruction. Okay, so store this R3 in the memory location A. Okay, then what you will do? What the fifth thing? Now you load B. Tell me, will you load this B again? Will you load this B again? Please tell me. We have already loaded B in R1. Yes or no? B is already available in R1. So you don't have to load this B again. So what you can simply do, just load E. Okay, just load E in register R4. Then what you will do? Now you can just do the subtraction. Yes or no? Now you can do the subtraction. Basically, what you will do? From R1, you will subtract R4 and the result you can store in R5. Then the result is in the R5, but where we want? The result we want in D, means in the main memory, we want the result. We want to store the result in main memory. So what you will do? You will use the store instruction. And basically this R5 you will put in the main memory. So tell me how many instructions you need in the RISC architecture. How many instructions you need? So total 7 instructions. 7 instructions. Now you tell me, if you have only 1 MB of RAM, means if you have basically RAM is expensive. Let's assume if RAM is expensive in the old days, then will you prefer this? Will you prefer this RISC architecture? Will you prefer? No, you will not prefer, right? Yes or no? But now notice something very interesting. What is that? How many memory cycles it will take? Okay, let's focus from the time point of view. Okay, now you tell me from the time point of view, how many memory accesses are needed? Just tell me just calculate the memory accesses. Memory accesses. Okay, how many memory accesses you need? This is you tell me. So you can easily see one memory access here. We want to load the value of B. One memory access here. We want to load the value of C. Here there is no memory access because all the operands are coming from registers. Here we want one memory access because we want to store the value in the location A. Here one memory access because we want to load the value in the location A into the register R4. Here there is no memory access because all the operands are coming from registers. Here another memory access because we want to store the value of R5 in the location D. So total how many memory access? 1 memory access, 2 memory access, 3 memory access, 4 memory access, 5 memory access. Yes or no? Only 5 memory access are there. Okay, so you can see here only 5 memory access. So tell me, from execution time point of view, which is better, CISC or RISC? From execution time point of view, CISC is taking 6 memory accesses, but RISC is taking only 5 memory accesses. So you can see the focus of RISC, that is on minimizing the execution time, and the focus of CISC, that is on minimizing the program size. So now did you understand? Please tell me, now did you understand that? Because this is the focus of CISC. Okay, CISC focuses on minimizing the program size. That is the reason it is using memory instruction. Is this clear? Is this crystal clear? Please tell me. Don't keep any doubt in your mind. Okay, what I'm telling you, please understand. The idea of CISC, that is to minimize the program size. We want to minimize the program size. Now you can see, to minimize the program size, you are using this CISC is using memory instructions. Okay, similarly, remember the focus of RISC, the principle, the ideology of RISC is to minimize the execution time. So if you want to minimize the execution time, then that is the reason you can see we are using register instruction. Why? Tell me, where is the benefit? Tell me, here you have only 5 memory access. In the CISC, you have 6 memory access. Why this 1 memory access you saved? What was the reason? What is the reason you saved 1 memory access? The reason is very simple, because you are not loading this B again. Yes or no? This B, this variable B, you are loading only one time in R1 and then you are using it anytime. Yes or no? So you can easily see, this is what I'm telling you. Very simple point. You understand that RISC. Okay, look at RISC. This will focus on what? This will focus on minimizing execution time. Minimizing execution time. That is the focus. That is the complete focus. Okay, so the focus of RISC, that is on minimizing the execution time. Okay, so RISC uses register instructions. So RISC uses register instructions. Why? Register instructions. What is the reason? Okay, so RISC uses register instruction. Why? The idea is very simple, because load the data in registers and then use it again and again. Yes or no? Is this clear? Please tell me. See why. Look at this. What is the reason? Just focus on what is the reason. Why? So RISC uses register instructions. Why? Because load the data from memory into registers and then use again and again. Yes or no? Load data from memory into register once. Okay, yes or no? Once, and use again and again. So this is called optimization. Let me tell you, this is called optimization. Basically, you are doing the optimization. You are doing the optimization. Okay, you are loading B only one time and then you are using it again and again. Okay, this is called optimization. So tell me one thing. If someone asks you, RISC uses register instruction, why? If someone asks you that RISC uses register instruction, that is fine, but why? Then what you will say? You will say that because using this register architecture, the optimization is easy. The optimization is possible. Yes or no? Using register architecture, what is possible? Optimization is possible. What is possible? Optimization is easy and possible. Okay, optimization is possible and optimization is very easy. So remember, optimization is possible and optimization is very easy. Okay, is this clear? What this optimization means? This simply means that load data from memory into registers. You have registers in your CPU, then use the registers. Yes or no? Then use registers again and again. Okay, so that is the reason you can see RISC uses register instructions to minimize execution time. Is this clear? Please tell me. To minimize execution time. And how this minimization is happening? Tell me. To minimize execution time. But how this minimization is happening? This minimization is happening because of optimization. Okay, this execution time you can minimize because of optimization. You can do the optimization. Okay, I hope this complete thing is clear. So please tell me, did you understand what is the idea of CISC? If someone asks you in the interview, you go to IIT, ISC interview, they ask you what is CISC, what you will say? What one line you will say? What is the idea of CISC? What is CISC computer? What is CISC architecture? What you will say? CISC architecture focuses on minimizing the program size, because in the old days memory was very expensive. So the focus was minimizing the program size. As an assembly language programmer, you should complete the task with minimum number of instructions possible. Okay, when you are writing the program for some task, then you should have minimum number of instructions, or I can say your program size must be very small, because in the old days memory was very expensive. Okay, so that is the reason this CISC means, the idea of CISC was basically to reduce the program size. But nowadays memory is not expensive, memory is cheap. Okay, so our focus is on the execution time. We want to minimize the execution time, so we use the idea of RISC computer. The idea of RISC computer is to minimize the execution time. Now remember, CISC computer wants to minimize the program size, so that is the reason it is using memory instruction. Because if you use memory instruction, then your program size will be very small. Okay, similarly, RISC computer, that will focus on the execution time. So the RISC computer is using register instruction, because when you use the register instruction, then you can do the optimization. Okay, you can use the data again and again. You load the data from main memory to registers, and then you use the registers. Okay, yes or no? You don't have to load again and again from main memory. So this is the idea for minimizing the execution time in RISC. So this is RISC versus CISC. RISC will focus on execution time. CISC will focus on size of the program. Please tell me, is this complete story? Did you understand? Is there any student who has already studied this RISC, CISC from some other institute or from some other resources? See, let me tell you what happens. If there is anyone here who is watching this video, and if you have studied from some other, I can say, institute, then what will happen? Let me tell you. They will tell you the differences of CISC versus RISC. They will create a table and they will put some 10, 15 points. They will put that in RISC, this will happen, in CISC, this will happen, in RISC, this will happen, in CISC, this will happen. So they will create a table, okay, some kind of table they will create, and they will do the differences. And a student does not even understand what is RISC, what is CISC. Are what is RISC? You tell me that. Don't tell me the differences of RISC and CISC. Don't tell me the differences of RISC and CISC. Tell me what is CISC. Why in the old days CISC was used? What is CISC? What is the idea of CISC? Okay, what is RISC? What is the idea of RISC? So basically, a student does not understand what is RISC, what is CISC. A student just by heart these differences. Okay, these 10, 20 differences, a student will by heart. Okay, he will, the student will rote learn, you know, and the student will think that I have understood. But the student cannot explain. If you have to explain to someone else what is RISC, what is CISC, the student cannot explain, because a student only knows what are the differences, and these differences also the student has by hearted. This is called rote learning. Yes or no? This is called rote learning. So I hope you understood. Please tell me, did you understand? Let me know. Okay, so now let's move on. So tell me the answer for this question. Tell me the answer for this question. Let me know. Which instruction set architecture is suitable for RISC, for CISC? Tell me, which instruction set architecture is suitable for RISC, which is suitable for CISC? So you can see register architecture. This is suitable for RISC because the focus is on execution time, minimizing the execution time. Memory instruction set architecture is suitable for CISC because the focus is on minimizing the program size. Is this clear? See, this why is important. If someone asks you why CISC uses memory instructions, can you explain? If someone asks you why, what is the reason why this CISC uses memory instructions? Okay, can you explain? Yes, you can explain, because what you will say? You will say the focus of CISC is to minimize the program size, because in the old days the memory was very expensive. That is the reason CISC uses memory instructions. Okay, so that is the idea. I hope this point is clear. Now you might be thinking why we call it complex and why we call it reduced. That is another thing that is going on in your mind. Agree? See, why we call it complex, like this word, why this word we are using, in the, okay, CISC architecture, the full form of CISC architecture, that is complex instruction set, and the full form of RISC architecture, that is reduced instruction set. Now, what is the significance of complex comma reduced? What that means? Please tell me what that means. What this complex instruction means, what this simple instruction means, what the difference? So let me tell you. Actually, you tell me the answer. I'm giving you two instructions. Okay, I'm giving you instruction number 1 and I'm giving you instruction number 2. Two instructions I'm giving you. The first instruction is this, that add R1, R2, R3. This instruction I give you. The another instruction that I'm giving you, that is add some location 1. Okay, let's assume this is memory address, this is memory address, this is memory address. Okay, so remember, these are memory addresses, because basically this is a memory instruction. These are memory addresses. Okay, because these are, you can see this is a memory instruction, right? Yes or no? So I'm giving you this memory instruction, and I'm giving you this register instruction. You tell me which instruction is complex. You tell me which instruction is complex. I'm asking which instruction is complex. Just use your common sense. Just tell me which instruction is complex. I'm giving you two instructions. Let's assume this is the instruction and this is the instruction. Two assembly language instruction I'm giving you. So which instruction is complex? You can see this instruction is quite simple, right? Because what this instruction will do? These are registers inside the CPU. These are registers. These are inside the CPU, right? Yes or no? These are inside the CPU. So in one clock cycle, you can execute this. Can I say? There is no memory access needed. There is no memory access needed. You don't need to access any memory. There is no memory access needed. First of all, there is no memory access needed. What you can do? This you can execute in one clock cycle. This you can execute in one clock cycle. In one clock cycle. In one clock cycle, you can execute this. Why? What is the reason? Because these are registers. These are available inside your computer. Inside your CPU. These are already present inside your CPU. So the ALU will take R2, R3. It will do the addition. It will put in R1. How much time it will take? Please tell me. Please tell me how much time it will take. Only one clock cycle is enough. Yes or no? Because registers are already available inside your CPU. Okay, so very simple. So register access, that is not expensive. You can access registers very easily because these are already very fast devices. Registers, these are very fast and these are all already available inside your CPU. So this instruction you can execute in only one clock cycle. Now focus on this instruction. Now please focus on this instruction. Now internally what will happen? You just tell me internally what will happen. You just tell me internally what will happen. This is your instruction. When you execute this instruction, then internally what the hardware will do? What the hardware will do? Tell me what the hardware will do. See, hardware will access B from memory. Okay, will access B from memory. It will access C from memory. Then addition will happen. Addition will not take much time. Okay, because once you have B, C in the ALU, then the addition can happen. Okay, is this clear? See, again, I am telling you what the most expensive operation. Please tell me in your computer, what are the most expensive operation? That is memory operation. When you have to access the main memory, that is the most expensive operation. Remember one thing, again, I am telling you, this addition operation is not expensive. The ALU can perform the addition very fast. Okay, register access is also very simple. Okay, you can do it in one cycle, in one clock cycle. This instruction you can execute. But you can see the most expensive operation, that is memory access. If you have to access the main memory, then many clock cycles will be needed to access the main memory. So you can see many clock cycles needed here, many clock cycles needed here. Okay, then the addition will happen and then the result you will store in the A. Yes or no? The result you will store in the A. So then addition will happen. Then addition will happen and then the result will be stored in A. Yes or no? So again, you will access main memory. Again, access memory to store result in A. To store result in A. So tell me, so did you notice this is called complex instruction? Is this understood? Please tell me. Is this understood? This is called complex instruction. So if someone asks you why this is called complex instruction, what is your reason? What is the reason? See, complex does not mean that. Okay, see, I have seen this many teachers in institutes. What they say that simple instruction like addition is a simple instruction. Okay, complex instruction like multiplication is a complex instruction. Arey, no, it's not the definition of simple instruction, complex instruction. You will see this. Okay, many students, they have this kind of misconception that okay, addition is a simple instruction, multiplication is a complex instruction, division is a complex instruction. Arey, no, this is not the point. What is the point? What is simple instruction? What is complex instruction? See, this is a simple instruction because you can execute this instruction in only one cycle. Okay, in only one or two clock cycle, maybe one clock cycle or maybe two clock cycle. So this instruction you can execute in only one or two clock cycle. There is no memory access required. So very easy. So this is a simple instruction. Similarly, this is complex instruction because here you need to access main memory. Yes or no? Here we need to access main memory and you need many clock cycles. This instruction will take many clock cycles. So tell me now, what is a simple instruction? What is a complex instruction? Tell me. If someone asks you, what is a simple instruction? Can addition be simple instruction as well as complex instruction? Is it possible? Can you make addition simple and can you make addition complex? Yes, very easily, because you can see if you use operands from registers, if all the operands are available in the registers, then this will become a simple instruction. Okay, and remember, if all the operands are available in the main memory, then this will become a complex instruction. So tell me, what is a simple instruction and what is a complex instruction? What is a complex instruction? So remember, simple instruction means these are your register instructions. These are your register instruction. So register instructions, these are called simple instructions. And what are complex instructions? What are complex instructions? These are your memory instructions. Your memory instructions, these are called complex instructions. Why? What is the reason why register instruction is a simple instruction? The reason is very simple, because can be executed in one clock cycle. Can be executed in one clock cycle. Okay, is this clear? Can be executed in one clock cycle. Here, this memory instruction, this is complex instruction because needs to access main memory. Needs to access main memory for operands. For operands. Okay, and hence takes many clock cycles. Okay, hence it will take many clock cycles. It will take. Okay, many clock cycles it will take. Is this clear? Please tell me. Is this understood? So it will take many clock cycles. Now you tell me. Now you tell me one thing. It will take many clock cycles. Execution time will be more. It will take only one clock cycle. Execution time will be less. So this will be used in RISC or CISC. This type of instructions, this type of simple instructions, they will be used in RISC or CISC. They will be used in RISC or CISC. See, the focus of RISC is for execution time. So you can see they are used in a RISC computer because the focus is on execution time, right? RISC means minimize execution time. Minimize execution time. Agree with me? Minimize execution time. Okay, so they will be used in RISC and they are used in CISC. The complex instructions, they are used in CISC. Why? What is the reason? What is the reason? What is the reason? They are used in CISC because the focus of CISC is not on the execution time. The focus of CISC is to reduce the program size. The program size must be reduced. The CISC does not care about the execution time. The focus of CISC is not on the execution time. Okay, all these points, are they clear? Please tell me, are they crystal clear? So now can you explain the CISC computer, why we call it complex instruction set computer, and RISC computer, why we call it reduced or simple? Reduced means simple. Reduced means simple. Okay, so simple instruction set computer. Is this clear? Why these words are coming? Complex instruction, simple instruction, are these points clear? Because you can see, if you have a register instruction, this type of instruction, if you have, then this you can execute in only one clock cycle. You don't need to access main memory. Okay, so this is a simple instruction. Okay, now you can see, if you have this instruction, then you have to access main memory 3 times. Okay, yes or no? So it will take many clock cycles. So this is your complex instruction. Very simple. Is this clear? Please tell me. Now tell me one more thing. In which instruction hardware will do more work? Tell me, in which instruction, this instruction or this instruction, to execute this instruction or this instruction, for which instruction hardware will do more work? For which instruction hardware is going to do more work? Please tell me, which instruction, for which instruction, this instruction or this instruction, for which instruction hardware will have to do more work? Yes, for this instruction. Yes or no? So you can see the CISC computer is hardware heavy. Is this clear? Please tell me, did you understand? Did you understand? So remember, simple instruction, if you have simple instruction, for example, if you have this type of instruction, add R1, R2, R3, if you have this type of instruction, and if you have complex instruction, okay, for example, this type of instruction like add memory location A, B, C. Okay, now you can easily see that the hardware, this is, I can see, this is not hardware heavy, right? I can say This is not hardware heavy. This is not a hardware heavy instruction. This is a hardware heavy instruction. Okay, yes or no? So this is a hardware heavy instruction. So remember, in the RISC computer, the focus is, or I can simply say that the hardware is very complicated. Okay, sorry, the hardware is complicated here. Okay, so in the CISC computer, you can see the hardware. Okay, I can say the hardware is complicated. Is this clear? The hardware is complicated in the CISC computer, and in the RISC computer, the hardware is not so complicated. Okay, the hardware is not so complicated. Is this understood? Please tell me. Okay, in the CISC computer, hardware is complicated. Okay, basically the focus also will be on the hardware. Yes or no? Just think about it. If you are writing only a very small program, means for every instruction you have to do a lot of work. For every instruction, the hardware has to do a lot of work. So naturally, the hardware will be complicated. You have to basically build a complicated hardware. Yes or no? Is this clear? In the CISC computer, in this computer, for every instruction, you are taking a lot of, you are doing a lot of work. For every instruction, you are doing a lot of work. So you can see that for CISC computer, the hardware will be complicated, and for RISC computer, the hardware will be not so complicated. Okay. So all these things, are they clear? Please tell me. Now let's just give, let me give you one example. Let me give you one example to understand what is RISC, what is CISC. Okay, very simple example I will give you. So you have a main memory. This is your main memory, and this is your ALU, and these are the general purpose registers. Now let's assume that, suppose we want to multiply. What we want to do? Just read this. Suppose we want to let the computer conduct one operation. What this operation will do? It will do the multiplication of two numbers. One number is stored at location 2, another number is stored at location 5 in the main memory, and you have to store the result in the location 2. So what you are doing? Tell me what you want to do. In the location 2, let's call it A. This location 2, okay, let me call it A. In the location 5, let's assume you have B. Now what we want to do? Now in the location 2, we want to put what we want to put in the location 2, in the memory. In the location 2, we want to put this A multiplied by B. Is this clear? Okay, this is what we want to do. This is the task. This is our task. This is our task. Now notice, for this task, what RISC will do or what CISC will do. Okay, let me quickly tell you. So for this task, if you are using a CISC machine, then what the CISC processor will do? What the CISC processor will do? This CISC processor, it will come prepared with one instruction. Basically, let me tell you, this is CISC computer. Remember, the focus of CISC computer is to minimize the program size. So what the CISC computer will do? In the instruction set, remember, this instruction set will contain multiplication. Okay, will contain this instruction, multiplication instruction. This multiplication instruction it will contain. So please understand that what will happen. See, this is our task. We want to multiply this A multiplied by B, and we want to store the result in this location. Okay, so this is what we want to do. Now what the CISC machine will do? The CISC machine will do this, that the instruction set of CISC machine that will contain this instruction. There will be an instruction MUL. This instruction it will contain. Okay. Now let me tell you one more thing. Basically, means the assembly language programmer can write simply this instruction. Okay. What assembly language programmer will do? Assembly language programmer only has to do this. Assembly language programmer will only have to do this. That's it. MUL location 2, 5. Is this clear? Please tell me. Is this clear? These are addresses. This is a memory address. This is memory address. So these are memory addresses. This is also memory address. This is also memory address. So the assembly language programmer will only write this instruction. Now remember one thing. Please tell me one thing. In the instruction set, you have this instruction. The CISC computer instruction set has this instruction. Okay, so the assembly language programmer only has to write this one instruction, and these are the memory addresses. Now you tell me, but how the computer will know what you have to do in the background, internally what you have to do, how that will be known? Please tell me how that will be known internally, what you have to do. See this MUL225. Okay, internally what you have to do, internally what will happen? Internally what will happen? Internally, first you will access memory location A, correct? Internally, first you will access memory location 2. Memory location 2 you will access. You will access memory location 5. Then the product will happen. Then the ALU will do the multiplication, and then what you will do? Then you will access memory location 5. Sorry, memory location 2 to store result. To store result. Is this clear? So these are the things that will be done. Please understand. These are the things that will be done. 2, 3, 4. But how the CPU will know? How the CPU will know? Please tell me. Internally, these things will happen. This is what programmer will write. Okay, assembly language programmer has written this instruction. Assembly language programmer task is very easy. Just write this instruction. So assembly language programmer will write just this instruction. That's it. Okay, that's it. Now, internally, these things will happen. Internally, these things will happen. Now you tell me how these things will, like how the CPU knows that these things to do for this instruction, how the CPU knows these things to do. Because remember, this is part of instruction set of this CISC computer. Instruction set will contain this instruction. Please understand. Okay, in this computer, in this processor, instruction set will contain this instruction. What it means? It means hardware knows how to understand and how to execute this. Is this clear? Please tell me. Okay, is this clear? Please tell me. So remember, internally the hardware knows. Who knows? Hardware knows. Okay, how to understand. Basically, hardware knows all these operations. Okay, let me call them operations. I am calling them operation. This, let me call it operation. Let me call it operation. Let me call this also operation. Basically, these 4 operations, right? Yes or no? So these are the operations. 1, 2, 3, 4. These are the operations. Is this clear? Okay, please tell me. Is this clear? So remember, hardware knows the operations for this instruction. Hardware knows the operations to execute. These are the operations to execute. Execute this operation, execute this operation, execute this operation, execute this operation. So these are the operations. So remember, hardware knows the operations to execute for MUL instruction. Okay, so is this clear? So remember, hardware has to do a lot of work. I hope this point is clear. Hardware has to do a lot of work. A lot of responsibility falls on the hardware. Okay, the responsibility is not on the programmer, because for the assembly language programmer, very easy, just write this instruction. The assembly language programmer will write this instruction and he will be very happy. The programmer will be very happy, but the responsibility will fall on the hardware, because remember, for this instruction, the hardware should know. The hardware must know what are the operations to execute. Okay, for this instruction, what are the operations to execute? Execute this operation, execute this operation, execute this operation, and then execute this operation. So what are the operations to execute? That should be known to the hardware. Okay, so the hardware should know, and hardware should understand. Everything hardware should understand. So remember, can I say that for the CISC computer, this is your CISC computer, so can I say the emphasis on the hardware? Can I say CISC emphasizes on hardware? Can I say emphasis on hardware? Can I say this? Please tell me. Emphasis is more on hardware. Is on hardware. Is this clear? Okay, basically hardware has to do a lot of work. I can say that hardware is complicated, or I can say hardware has to do a lot of work. Has to do a lot of work. Hardware has to take a lot of responsibility, I can simply say. Okay, so this is the point. So remember, emphasis is on the hardware in the CISC computer. Is this clear? What the CISC computer will do? Okay, this is our task. We want to multiply. This is our task. So you can see to complete this task, very simple. The CISC programmer, what it will do, he will just write one line of code. Do you agree with me? Is this clear? Please tell me. This is our task. To complete this task, I want to complete this task. To complete this task, the CISC programmer, the assembly language programmer who is working on the CISC computer, he will just write only one line of code. That's it. Now, the responsibility will fall on the hardware. Now, the hardware has to understand what is this. Okay, so the hardware has to understand what are the operations to perform to execute this instruction. If you want to execute this instruction, then internally, what are the operations that you have to execute? So that should be known to the hardware. So that is the reason I am saying that in the CISC, emphasis is on the hardware. Hardware has to do a lot of work. Is this understood? Please tell me. And what the RISC will do? What the RISC will do for the same task? What the RISC will do? Please tell me. For the same task, this is our task. Remember, memory address in this location, you have to put A multiplied by B. Okay, so tell me what the RISC will do. On the RISC computer, what the assembly language programmer has to do. If you are the assembly language programmer, then what you have to do? If you are the assembly programmer, then what you have to write? First, you have to load, yes or no? First, you will load. So you will load this A in some register R1. Then you will load this B, sorry, location. Okay, let me write location here. The location, because this is address. This is memory address. Okay, because ultimately what you want that in the memory location 2, you put memory location 2 multiplied by memory location 5. This is what you want. Okay, this is what you want. So what you will do, very simple. In the RISC computer, the assembly language programmer, what he will do, he will load whatever data you have at this location, whatever data you have at this address, you will load in R1. Then whatever data you have at this address, you will load in R2. Then what you will do? Then you will do the multiplication. Okay, let's this, or I can say for simplicity, let's say product. Okay, ALU will do. Who will do? ALU. This will be done by the ALU. So the product, ALU will do the product. Okay, R1, R2 and store in R3. Okay, just do R1, R2 and store in R3. And then what you will do? Then you will store. Okay, then you will store this result. You can store in the memory location 2. Is this clear? Please tell me. So can I say assembly language programmer has to do some work? Do you agree with me? Can I say assembly language programmer has to do some work? Has to do some work? Agree with me? Assembly language programmer has to do more work than the CISC, than on the CISC computer. See, programmer, this assembly language programmer on the CISC computer, he will just write one instruction. Okay, this programmer, this assembly language programmer on the CISC computer, okay, for this task, to execute this task, to carry out this task, this assembly language programmer will write only one instruction. Okay, so I can say work is easy for programmer. Programmer's life is very easy on the CISC computer. On the CISC computer, programmer's life is very easy on the CISC computer. But on the RISC computer, what will happen? On the RISC computer, the programmer has to write this. This is what you have to write. The programmer has to write this. So I can say programmer's life is not easy on the RISC computer. Do you agree with me? On the RISC computer, programmer life is not easy. Okay, this is what you will do. Okay, so I hope you understood all these points. Please tell me, is everything clear? So what the CISC will do, what the RISC will do, everything we have seen. Now, just tell me a last point. Nowadays, do you do assembly language programming? Nowadays, do you do any assembly language programming? You don't do that, right? Okay, nowadays you will write the C language code and the compiler will convert into the assembly language. Now you tell me, in the CISC and in the RISC, on which system compiler has to do less work? Please tell me. On the CISC computer, on the RISC computer, on which, let's assume there is a CISC computer and there is a RISC computer. On which, you tell me, the programmer, the compiler will do less work. Please tell me. So here you can see the assembly language programmer's life is very easy. I can say here, assembly programmer, the assembly language programmer life very easy. Okay, here I can say that assembly language programmer's life is hard. Yes or no? Assembly language programmer has to write the code. Assembly language programmer assembly programmers life hard. The same thing I can say for the compiler also, because compiler will convert the high language code into the assembly language code. Now, can you say the same thing for compiler? Please tell me. For compiler, on which CPU compiler will do more work? Please tell me. On which CPU compiler will do more work? Please tell me. On which CPU compiler will do more work? Please tell me. On which CPU compiler will do more work? Means compilation is easy here, right? Here compilation is easy and here compilation is hard. Okay, on the RISC computer, compilation is hard. Okay, compilation is hard. But on the CISC computer, compilation is very easy. You just have to write one instruction, very simple. And here you have to write many instructions. So that is the reason here compilation is hard, here compilation is easy. And you can easily see this is hardware dependent. I can say this is hardware heavy. Okay, and this is I can say, see, here the focus is on the compiler. Notice. Here the hardware is doing all the work. Okay, in the CISC computer, hardware is doing more work, but in the RISC computer, compiler is doing more work. So can I say this is software heavy? Yes or no? Means here software will do more work. Is this clear? Are you getting my point? What I'm saying? See, CISC CPU, if you look at CISC CPU and if you look at RISC CPU, this is what we have seen, that here you can notice hardware has to do more work. Yes or no? Here you can say hardware does more work. Hardware does more work. And here compiler will do more work. Compiler means software, right? Okay, means a software. Okay, that does more work. That has to do more work. Okay, so that is the reason I can simply say, you can just say that here emphasis on hardware. Here the emphasis is on hardware. And here emphasis on software. Okay, is this clear? Please tell me. So all these points, are they clear? You can read. See, these screenshot you can read. Okay, we have seen everything. In this screenshot, whatever is written, we have seen. What you can do, you can read. I will upload the annotated notes, you can read. But I'm telling you that whatever is written on these screenshots, these are taken from standard resources. Okay, from universities, from top universities. I have taken these screenshot. You can just read this. Whatever is written here, whatever is written, that we have already seen. Okay, so you can read this. You can read this paragraph also. Okay, so you can read this. This is from Stanford. You can see this screenshot I have taken from Stanford. You can read. Okay, just do the self read, because whatever is written here, we have already seen. If you remember this multiplication example, we have already taken this multiplication example. Everything I have already told you. Okay, what the RISC will do, that also is written here. You can just see. So in the RISC, hardware is simple, right? Yes or no? Can you notice? Just notice some things, that in the RISC, hardware is simple. In the CISC, hardware is complicated. In the CISC, hardware is complicated. Okay, is this clear? But you can see in the CISC, look at CISC. In the CISC, compiler has to do very little work. Read this line, please read this line. In the CISC architecture, compiler, or I can say the assembly language programmer, has to do very little work. Okay, but you can see the hardware is complicated. Here in the CISC architecture, the hardware will be complicated. Okay, next you can see in the RISC, if you notice, in the RISC, the hardware is simple, but the compiler has to do more work. Okay, hardware is very simple, but the compiler has to do more work. Okay, compilation is not easy. Is this clear? Please tell me. Okay, so all these things we have seen. Now, a very small point I just want to ask you. Tell me, if you have a program, how much time it will take? How to decide that you have a program execution time? I'm asking program execution time. How to find that? Program execution time. Can you write an equation? You have a program. Now I want to ask you, what is the program execution time? So how to do that? See, what I can say, number of instructions in this program, You have a program. This is your program. Let's do. Okay, this is the program that you have. Now I'm asking that what is the program execution time? What is the equation for program execution time? So how you will write? Very simple. Number of instructions in this program, number of instructions per program multiplied by what? Multiplied by what? Means how many instructions you have in this program. Okay, these instructions, how many instructions you have in this program multiplied by what? Per instructions, how many cycles you are taking? Yes or no? How many clock cycles you are taking per instruction? Is this clear? Per instruction, how many clock cycles you are taking? Number of clock cycles per instruction. Means for every instruction, how many clock cycles you are taking? Multiplied by, for every clock cycle, what is the time? Okay, time per clock cycle. Yes or no? Time per cycle. Time per cycle. Tell me, did you understand this? Very intuitive, very intuitive. You have a program. You have this program. I have given you this program. What is the program execution time? How to represent program execution time? That will be how many instructions are there in this program? Number of instructions per program multiplied by every instruction will take how many clock cycles? Number of clock cycles per instruction multiplied by, in every cycle will take how much time? Every clock cycle will take how much time? So is this clear? Please tell me. Time per program. This is the execution time for every program. How much time every program will take? That is equal to number of instructions per program multiplied by number of cycles per instruction multiplied by how much time every cycle will take. Okay, a very simple question I'm asking you. You just tell me the simple point. Let's call it A, let's call it B, and let's call it C. Tell me what CISC will minimize and what RISC will minimize. Tell me what CISC will minimize and what RISC will minimize. Which of these quantities CISC will minimize and which of these quantities RISC will minimize? Tell me what quantity CISC will focus on minimizing and what quantity RISC will minimize. Please tell me. Let me know. This is the program execution time. See, this overall, this complete thing is program execution time. Means how much time you will take for every program. For any program, how much time you will take. That is equal to how many instructions are there in this program multiplied by how many cycles every instruction will take multiplied by every cycle will take how much time. So these are the quantities A, B, C. You tell me what CISC will minimize and what RISC will minimize. See, CISC will minimize number of instructions per program. So CISC will minimize C, number of instructions per program. That is the focus of CISC. CISC will minimize the size of the program and RISC will minimize every instruction. For every instruction, how many cycles you will take. Yes or no? Okay. RISC will minimize execution time for every instruction. Execution time for every instruction. And this will minimize the size of the code. Is this clear? Please tell me. So CISC will minimize this quantity and RISC will minimize this quantity. Okay. So you can see here. Okay. Very simple. You can see the CISC approach will try to minimize size of the program, will try to minimize number of instructions per program. And the RISC will minimize number of cycles per instruction. Okay. It will minimize number of cycles per instruction. Very simple. Okay. All these points, are they clear? Now, a sequence of questions I will ask you. The topic is over. You understood what is CISC, what is RISC, everything you understood. Just a series of questions I'm asking. The topic is over. Don't worry. Everything we have seen. Now you just tell me a series of questions. The answers you tell me quickly. Tell me the answer for this question. Quickly tell me the answer for every question. CISC versus RISC. Memory to memory instruction set. Who will use memory to memory instruction set? Who will use memory to memory instruction set? CISC will use. Okay. And register to register instruction set. Who will use? RISC will use. Okay. Very good. Very good. Excellent. Next. Tell me the answer for this question. Who will have more number of registers? More number of registers. Who needs? Which architecture needs more number of registers? RISC, because RISC will use register instructions. Okay, less number of registers in CISC. Tell me the answer for this. Tell me quickly the answer for this. Load and store, they are incorporated in the instructions. Okay, load and store, they are part, basically they are internally, they are happening in the instruction. Load and store incorporated in the instructions, that will happen in CISC. Okay, and load or store, these are safe independent instructions, that will happen in RISC. Okay, because see what this means, let me tell you what option A means. See, for example, sorry, hi everyone, is the screen visible? Please tell me. Okay, so what I'm saying, what I'm trying to say, so did you notice, did you understand the option number 1? Did you understand the option number 1? Okay, so you can see the option number 1 is saying, the option number 1 is saying load and store, they are incorporated in the instructions. For example, if you look at CISC, okay, in this CISC, we are using memory instruction. We are using memory instruction set. Okay, so for example, if you look at this add, okay, add ABC. Now internally all these things are happening. If you look at this internally, remember, internally load and store are happening. Internally load store happens, yes or no? Internally load memory store memory happens. Internally load store happens. Okay, load store, that happens internally, that happens internally, it happens. Okay, is this clear? Very simple. So this is the point. And load and store, they are independent instructions, that will happen in the RISC. Okay, so all these things. Tell me the answer for this question. RISC and CISC, in which of them hardware is easy? Hardware, which of them is highly dependent on hardware? RISC, CISC, which of them is highly dependent on the hardware? You can see CISC is very heavily dependent on the hardware, right? Yes or no? Hardware is complicated, and RISC, that the emphasis of RISC, that is on the software. This is for RISC. Okay, very simple. Is this clear? Okay, so all these differences are there. What is RISC, what is CISC, we have already seen. Just let's see. Both are instruction set architectures. We already know RISC, reduced set instruction set computer. Okay, this is faster. RISC is faster. You already know. The hardware is simple. You already know. Yes or no? In a RISC computer, the hardware, in a RISC computer, hardware is very simple. RISC computer is faster. More instructions per program, that also we know. Yes or no? Agree with me? More instructions per program. In the RISC, we have more instructions per program. We have already seen, if you remember, there were 7 instructions, if you remember, for this for a very simple 2-line code. Okay, for this a plus b, a equal to b plus c, and d equal to b minus c. For this, you can notice there were 7 instructions here. There were 7 instructions here, but in the CISC we have only 2 instructions. So you can notice that in the RISC you have more instructions per program. CISC means complex instruction set computer. This is slow. Okay, this is slow. You can see the hardware is very complicated. The hardware is complex. You can see there are few instructions per program. Basically, the size of program is very small. Okay, so these are differences. All these differences we have seen. CISC versus RISC. In the CISC, emphasis on the hardware. In the RISC, emphasis on the software. In the CISC, every instruction will take many clock cycles. Do you agree with me? In the CISC, every instruction will take many clock cycles. So in this CISC, you can notice multi-clock complex instructions are there in the CISC. Okay, we have already seen this. In the CISC, every instruction, if you look at any instruction, that will take many clock cycles. So those are complex instructions. In the RISC, every instruction will take only 1 clock cycle, single clock. Okay, yes or no? Single clock cycle. Every instruction will take only 1 clock cycle. So basically the instructions are very simple. Okay, you can see in the CISC, we use memory to memory instruction set. So the load and store, they are incorporated in the instructions. Similarly, in the RISC, we use register to register instruction set. So load and store, they are independent instructions. Okay, so all these points we have seen. In the CISC, the code size is small. Yes or no? You have a small code size, but remember the time will be more. Time taken will be more. In the RISC, time taken will be less. Okay, the execution time will be less, but the size of code will be large. Okay, larger code size. So you can see in the CISC, you can easily see hardware is complex. So remember, you have complex hardware. So if you have complex hardware, then you need more transistors. In the RISC, we have easy hardware. The hardware is not complex. Okay. So all these differences we have seen. RISC versus CISC, all these differences. Now, did you notice one thing? Let me tell you one thing. Okay, this is you might feel this is very surprising. In most of the, I can say, whenever you will see this RISC versus CISC in other institutes, okay, many teachers, what they will do, they will start from this table. Okay, let me tell you, we are ending on this table and they will start from this table. Okay, you can see this. Okay, so this is the difference. So remember, we are ending with this table. This lecture, we are ending with this table, and many, I can say, many YouTubers, or I can say teachers, they will start with this table. Okay, so anyway, so you can see CISC versus RISC. In the CISC, emphasis on the hardware. In the RISC, emphasis on the software. In the CISC, multiple instruction sizes. Okay, that we will see, don't worry. Okay, you can see in the CISC, you have less registers. In the RISC, you have more registers. Now, you can see all these things. Now, let me tell you, in the CISC, pipeline is very difficult. Pipeline means parallelism. Pipeline means parallelism. This point we have already seen, if you remember. Pipeline means parallelism. So tell me, in which of them parallel? Okay, so what is the spelling? What? I think this is the spelling. So pipeline, you can understand that pipeline means parallelism. So tell me, who has more parallelism? Let me know. Who has more parallelism? If you remember, I have already told you this. The RISC has more parallelism. Yes or no? In the RISC, the parallelism is easier. Okay, so pipeline means parallelism. And in the RISC, pipeline is easy. In the RISC, pipeline is easy. Optimization is easy. Okay, the instruction will take only one cycle. The instruction will take only one cycle. In the CISC, instruction will take many clock cycles. Okay, so all these things we have seen. Okay, so that's it. This is your chapter. Please tell me, did you understand? Let me know. Did you understand? Please tell me. This RISC versus CISC, this story, will you ever forget? If someone asks you what is RISC, what is CISC, can you explain? Please tell me. What is RISC architecture? What is CISC architecture? If someone asks you, can you explain very clearly? Tell me. All these differences, the difference of CISC, RISC, all these things, are they very simple now, right? Yes or no? So please tell me, did you understand? Let me know. Okay, so this is your lecture, CISC versus RISC. We have seen everything. Okay, so I hope you understood. If you understood, please comment. Okay, please share your feedback. Okay, so that is my request, that whenever you watch any video on the GoClasses YouTube channel or on the GoClasses website, please share your feedback. Okay, so if you are watching on the GoClasses YouTube channel, if you are watching any lecture on the GoClasses YouTube channel, then this is my request, that please like, comment. Okay, so please share your feedback in the comments and please like the video. Okay, so thank you everyone. I hope you understood everything. Okay, so thank you. See you in the next lecture. Okay, thank you.